Greetings and welcome to the Engineering by Design and Early Learning presentation. My name is Ryan Novitsky and I'm the STEM CTL Director of Learning.
And my name is Darcie Jones. I'm the STEM CTL Director of Innovation.
And Dr. Lauren Beal is your State Consortium Director, and our point of contacts are directly under our names. The objective for today is to analyze early learning education via Engineering by Design. And our agenda, with our items and topics to talk about, is the introduction to Engineering by Design, a question comments portion, a presentation on the STEL, or Standards for Technological Engineering Literacy, and navigating the Media-Rich Edition and Standard Edition for all of our courses. If you have any questions or comments, please make sure to reference the bit.ly link on 2 or 1 on the slides to get the slideshow and utilize this form to place any questions or comments you may have. We will respond to you in a timely manner within 24 to 72 hours. Engineering by Design is a program that is built on the belief that the ingenuity of children's untapped, unrealized potential that, when properly motivated, will lead to the next generation of technologists, innovators, designers, and engineers. Hyperlinked in here when you left-click on the bit.ly link will bring you to what Engineering by Design is overall. Engineering by Design has an integrative STEM education approach, which can be defined as below of the application of technological and engineering design-based pedagogical approaches to intentionally teach content and practices of science and mathematics education to the content and practices of technology and engineering education. It is equally applicable at the natural intersection of learning within the continuum of content areas, educational environments, and academic levels. Pennsylvania, which is part of our EBD consortium, is part of these 4 circles. Engineering by Design has an assessment-based driven curriculum in which you can deliver pre-assessments and post-assessments and embed assessments within your content to analyze your students' overall growth throughout the year. We are research-based, in which we use standards to drive our curriculum, and we revise our curriculums annually or every 2 years or as needed based upon the needs. We offer professional development and learning opportunities each year in a wide array of ways. We are a standards-based curriculum driven by the STEL, the Standard for Technological Engineering Literacy, the NGSS, Common Core, Grand Challenges for Engineering, and Engineering Habits of Mind. We are a pre-K to 12 sequence of learning, which means that we have courses that start as early as pre-K going all the way to 12th grade. Our focus today is pre-K 6. There are additional middle school curricula that are supplemental units or enrichment units, such as vertical farming and the World in Crisis. The model that we use overall is our 6E Learning by Design model, in which we use an engage, explore, explain, engineer, enrich, and evaluate lesson plan model. And as we go through the Media-Rich Edition, we'll explain a little bit more in detail what a 6E lesson plan really is, and the major difference between our content and opposed to other contents is that we like to really focus on the little e in engineer, which means that we are equipping students to be problem solvers, learning how to apply concepts, practices, and attitudes towards being critical thinkers, analysis, etc. Not necessarily to become engineers, but to have those skill traits to become successful in any profession. Our Media-Rich Edition enables the educators to utilize a learning management system that is our Buzz platform, in which you'll be able to analyze what students did or did not reach your overarching standards for diagnostic purposes and reflecting purposes throughout the year. Within our consortium, we are continually researching and working collectively together to develop new content to implement within all of our content and curricula pre-K 12. And our headquarters staff is listed at the bottom as well. Now, I'm going to pass the baton on to Steve Barbado to present on the Standards for Technological and Engineering Literacy.
Standards for Technological Literacy are something that came about in the year 2000, but in this presentation, I'm going to be sharing with you a lot of information about the new standards, which are Standards for Technological and Engineering Literacy, which were just completed in July of 2020. So as I go through this today, we're going to be talking about how ITEEA provides products, services, and supports for all educators to engage all students through active learning in a design-driven, integrative STEM education classroom. So the standards were produced in July of 2020, and since then we've been putting together a variety of resources on the website, which I'm going to highlight as we go through this process. The importance of technology and engineering is something that has been lacking in our normal school system over the decades. And with this new emphasis that the National Science Foundation and Technical Foundation of America have funded and sponsored, with our efforts, we've put together a program that we think will really launch a new effort to better explain the role of technology and engineering in STEM education. So there are groups out there like the National Assessment of Educational Progress and the NAEP TEL Assessment, Technology and Engineering Literacy Assessment, that's out there that really reinforces what we're trying to do and how we do it. And better yet, students that have the time to go through a program that's following these standards will be better prepared on these national assessments. So we redefine technology and engineering as the ability for these programs to be integrated, design-based, to be making sure that we dot the I's and cross the T's in all the technology and engineering aspects as we go through all the different facets from pre-K through 12. There are 3 dimensions of learning that have been a part of technology and engineering for the past 100 years in our association, and that's knowing, thinking, and doing. And the knowing part is organizing it, understanding it, making sure there are factual as well as conceptual relationships. Thinking, making sense of information through questioning, analysis, decision-making, and doing, using technology and engineering in applied ways. It's also engaging students to make it fun. It's actually creating in STEM education a way to engage students so that they have a way of controlling the world around them. We focus on a small e. What does a small e mean? It means that it's a verb to use engineering design and the application of engineering habits of mind so that students become thinking like engineers. They don't have to be an engineer as a noun, so civil engineer, mechanical engineer, etc. But they need to be able to think like an engineer to be able to cope with the rapidly changing focus of our world. So as we go through, and I'll highlight some of the features of STEL, we have in this octagon, set of 3 octagons, the standards as the core. That's that gold center in the middle. There are 8 core standards for technology and engineering literacy connected to 8 practices. So in the big picture of things, all 8 standards, pre-K 2, 3, 5, 6, 8, 9, 12 for the grade bands need to be taught through the 8 practices that you'll see there. Everything from collaboration, communication, and attention to ethics, to systems thinking, creativity, making and doing, optimism, and critical thinking. So that's a real key. And as we do that, we're going to be connecting them through a variety of contexts. So the standards are those 8 in the center. The red part are the practices. All of those must be taught all the time. And it's done through a variety of different contexts that you drive from your decision making. So as we look at these, we used to have 20 standards in the old standard set, the STLs. We used to have 288 benchmarks. Now we have 8 standards and only 142 benchmarks. Much more realistic and doable in today's world. So as we look at these 8 core standards, we have the ability from these to be able to break those out by grade level, as we were talking about, and create benchmarks that must be realistic, but also driven and with a high benchmark. So as we went through this, we decided to make sure that students have both the hard skills, the formal skills, as well as the soft skills that connect to technology and engineering through these practices. The technology and engineering standards and practices are then taught through these contexts. And there's an example on the screen. The domains of learning are connected to the technology and engineering dimensions, but most importantly, we have the student outcomes connected to each one. We have a lot of references and resources for those. Each of the standards are highlighted with a variety of key ideas, and also it walks the teacher through how, and the educator who's developing the curriculum what is technology, what is engineering, what is the science, what is the mathematics. And these are all connected as we go through all the way up through grade 12. So in recommendations using STEL, we use an ABCD approach for converting benchmarks to instructional objectives. A is for audience, B for behavior, C for condition, and D for degrees of mastery. So there's an example there as we go through them. You can reference those. I did a presentation for Illinois the other day, and Darcie helped me do some research on it. But I left this in here for this group because no matter what the context, this one is virtual reality and augmented reality. There are ways to connect it through those contexts to those 8 core standards and the 8 practices. A critical piece. There's some cool resources here as well that are connected to the Caterpillar Foundation and then connected back to our contexts with those 8 areas that are listed there. And then the disciplinary standards connected then with the benchmarks. We also have resources that have all the STEL benchmarks, the Standards for Technological and Engineering Literacy, connected directly to the approved Next Generation Science Standards and the Common Core State Standards for Mathematics and English Language Arts. So we've already done that homework for everybody, and that's sitting there on our website ready to go. So this is an example, for instance, on STEL Core Standard number 7, Design in Technology and Engineering Education, and the valid matches that go from the STEL to the NGSS to the math to the ELA. And then again, in different grade levels, this is 9 through 12. We also have then a connection for the cognitive, affective, and psychomotor areas with the verbs, and a connection then to the knowledge of dimension. And that's done for every standard. So they're available for download free. You can have a printable version for a small fee, an EPUB edition, and print version for a small fee as well. We're working real hard right now to continue developing online resources, and one of those is a STEL lesson plan template. We're hoping that everybody can take advantage of this. It's going to have online and fillable areas suitable for all subjects. Efficient writing and alignment with STEL will be the end result. And with that, we're going to be focusing on the 6E model of lesson planning. It's the 5E with an added focus of engineer to apply, conceptualize, inform design, modeling, and create. The lesson plan format then, we're just finishing up right now, and there'll be some examples on the website very soon. But we're hoping that by our spring virtual conference that we'll have a tool ready to go in place for all teachers to use, and a web app as well as a mobile app. So the additional resources that are on the website, benchmark crosswalks, marketing resources, a variety of different research documents. And the deal is we want to make sure that everybody gets into this call to action, that everybody understands what technology is, what engineering is, and more importantly, what it takes to make sure that every student can become technologically and engineering literate. They need to have the ability to understand, use, create, and assess the human designed environment that is the product of technology and engineering activity. Critically important. So help your school system move forward, be a part of understanding what STEL is and how to apply it, share it with your administrators, and also come to the website. We have a Q&A area on there through the Idea Garden that you can ask questions, and feel free to shoot emails to us.
Now we're going to take a moment to navigate through the media-rich edition to talk about exploring technology, as well as Grade 3 Teams, Grade 3, Lesson 3. In order to get to the Buzz portal, you want to go to ita.org, left-click on EBD Buzz, and when you're at EBD Buzz, put in your login credentials, log in, use as a teacher, and if you clicked by accident, you can always go to the 9 dots and click Teacher over there. And then afterwards, you're going to go down to the applicable course, which we will highlight Exploring Technology. We will highlight in this course the first 5 days, and what the first 5 days are within this course, or any courses from 6 to 12, and specifically this one for grade 6, we highlight what is done for the first 5 days of school. Within here, equips the educator with all the arsenals to teach the course effectively for the first 5 days of school. The very first day of school, what they're going to be doing is a school recycling design challenge. The big idea, purpose, duration, and standards are listed right here on the overview. In addition, you'll have your 6E lesson plan from Engage to Evaluate within the KSB or the Knowledge Skill Builder, which are embedded throughout the entire content for Exploring Technology. And as I navigate a little bit further, you'll notice all the resources are populated for you. And the overarching goal for this individual day for day one is to create a new plan for recycling your school. So what this is referring to for day one is that the students will be working collectively as a partner or in groups to create a new plan for recycling your school on the very first day of school, so you're able to gauge where the students are overall for problem-solving techniques to be utilized in your classrooms. Now I'm going to pass the baton on to Darcie to talk about Grade 3, Lesson 3.
So we're going to take a look at the EBD Teams Grade 3. So what does TEAM stand for? This stands for Technology, Engineering, Environment, Math, and Science. So within the main landing page, you will see a course description, you will see safety resources and guidelines, a welcome to EBD, the course introduction, and then a series of different lessons. Each lesson is set up very similar, where if you open these arrows, you can see what's in the lesson. If you collapse them, you will close it. So we're going to take a look at Lesson 3, Introduction to the Engineering Design Challenge. You can open the overview by left-clicking or clicking on the play button. Within your lesson, you can navigate to the previous lesson or activity with the arrows found at the top, or you can use the back arrow to go back to that main landing page for this course. So in this lesson overview, students will be introduced to a design challenge. Students design and engineer a model of clothing, footwear, or other device that reduces the impact of wet weather or a wet weather-related hazard. Within these lessons, you will see an overview, the big idea or purpose of the lessons, sometimes enduring understandings, the lesson duration, and the 6E lesson highlights. This lesson will focus on Explore. If you navigate to the next activity, you will see the standards. Navigating to the next activity, you will see the learning objectives. So in this lesson, students will discuss a design challenge, develop an understanding of the attributes of design, and develop an understanding of engineering design. The next activity is the 6E lesson plan for the teacher. It goes through the overview. Again, in this lesson, it focuses on Explore. So students will construct their own understanding of clothing and/or footwear through the engineering design process. It gives the teacher the procedures in order to prep and prepare their lab or classroom space, step-by-step preparations and procedures, including discussion points for your students and how to implement and instruct them to work through this design challenge, a list of materials that you will need, an extensions portion, and very important, safety and conduct. So it mentions here that materials are included in supporting files. If you navigate to the next activity, you will see supporting files. So in this example, there's a design challenge. You can use the pop-out feature to open in a browser tab. You can also download them using the attachment file here. If you navigate to the next activity, you will see an assessment. In this lesson, the assessment is a rubric. With the Media-Rich Edition, the MRE that you will see at the top, this allows you to conduct pre and post data and keep track and monitor your students' progress within this Buzz portal. I'm now going to pass the baton back to Ryan.
All right, I also want to take one more moment to focus on a standard edition. What is a standard edition? In the state of Pennsylvania, all the resources to actually having a standard edition are available to you. The standard edition is the same thing as a media-rich edition, except there is no access, as mentioned before, to the data and assessments that are utilized within the Buzz version. And you're able to download them directly through your STEM by State portal, and the content and curriculum overall is the same, and all the activities are embedded within the PDF. You need to reach out to EBD State Consortium Director, Dr. Beal, for further information on locating the resources or accessing resources as needed. And again, all the activities, resources, lessons, course overviews overall are embedded directly within your standard edition. And I think it's even equally important to note that the lessons within your EBD team's content or curriculum are typically speaking going to last for a duration of 1 to 6 weeks. And the reason I want to make note of that is that when looking at this, you'll notice the time requirements of 30 to 60 minutes, the lessons that accompany it, because these are meant to embed with your curriculum as they are integrated or utilized throughout the year. Thank you for our presentation, and I hope you have a wonderful day and evening.
Thank you.